Thank you very, very much. It's such a pleasure to be here. So I'm going to tell you a little bit of a story about a project that I've been involved in, which has really benefited from everything that Emily's just talked about. Yeah, she's just set it up perfectly. So before I start my little story, I should tell you a little bit about myself as well. I would call myself a biostatistician. Most of my career up to date has been developing methodology to deal with really messy types of data to answer questions, mainly of an epidemiological nature. But I deal a lot with missing data and how you can still get a valid analysis when there are missing observations missing on individuals. And I'll come back to that in a little bit. But this story is not a story about myself, it's a story about a team and who got together. We call ourselves the COALESCE team, and everyone is listed here. It was really led by Professor Kathy Sudlow and Aziz Sheikh, and there were teams from the 4 nations, from England, from Scotland, from Northern Ireland and Wales. I think because I said I was a statistician, people are leaving. I live with that. But what I really want to kind of stress here is this public and patient involvement. We knew that we needed to include members of the public and patient in this particular study. I'll tell you more about it, because we're dealing with really big data here, and if we lose their trust, stories spiral, and we needed to kind of have this firm foundation of not just gaining trust but maintaining the trust of members of the public and patients. And this team came from a number of institutes and other partners, including Aberdeen, University of Bristol, UCL, Cambridge, Leicester, Strathclyde, Belfast, and so on. So what did we set out to do? We wanted to investigate the risk of severe COVID-19 outcomes which were associated with being under-vaccinated from COVID. And we wanted to do this using the whole population of the UK, of England, Scotland, Northern Ireland and Wales. We took a study period, which was the summer of 2022. And we went into the national trusted research environments that Emily just talked about. So these were held nation-specific, so there were 4 of them. And within those secure data environments or trusted research environments, were data from primary care records when you go and see the doctor, from hospital admissions, from COVID test data and vaccination data and death data. And this data was available to access to researchers who had this accreditation that Emily talked about, and they were able to go into these TREs and perform the analyses that were of interest. This was a huge task. These data sets are massive, the biggest one being England, which holds data on 58 million people. And there were some challenges of handling data that is that kind of long. And as Emily said, all these outputs from these different trusted research environments are examined by human data governance to ensure that we're not disclosing sensitive data. And then we get all the results from the 4 nations and then perform a meta-analysis at the end. So this is our UK-wide network of national secure data environments, one for England, Scotland, Wales and Northern Ireland. And there's a history of all of these. The newest one, the Northern Ireland one is in development, and that's quite exciting at the moment that primary care data is coming through for that. But at the time, the newest one was for England, that it didn't exist before COVID, and COVID really helped the development of the secure data environment by the NHS England. And this is an example of the NHS England secure data environment. So there's data in the middle that's held by NHS England. So that includes the hospital data, the primary care data, some of the dispensing data. But there's other information that we want to link with that. Emily talks about the strength of linking data. So we can link the cardiovascular registry records, cancer records, and registries are being linked. And then we can also link the COVID-19 lab and intensive care data. And so this is linked on our NHS numbers here in England and other identifiers when that wasn't possible, and then moved into the secure data environment where researchers can then access and analyse. So that's kind of like the framework of a typical secure data environment. But back to this study and back to this story. What do I mean by under-vaccination? It's actually defined as having received fewer doses than recommended on the 1st of June 2022. So we took that single time point I think everyone in this room is between 16 and 74. So you were under-vaccinated if you hadn't received your 3 doses by that date. And the outcomes we were interested in were severe COVID-19 outcomes. So that included hospitalization for COVID or death from COVID. And the first task we had was doing this data curation, cleaning it, getting rid of people who died before they were born, of pregnant men, and also dealing with the complexities of sometimes people would have several recordings of a characteristic that we wanted to get out, like ethnicity. So each time they'd see their GP or go to the hospital, they'd actually record a different ethnicity. So trying to make these rules to kind of curate it consistently, not just in one data set, but across the 4 data sets. And that was a big challenge to achieve. And then it came to our analysis approach. This was a straightforward logistic regression and a Cox regression, but you cannot run these types of regressions on 57 or 58 million people in a TRE that doesn't have kind of the capabilities of running that. So we had to kind of do what I call a weighted regression, where we would get all the cases and subsample controls and do analysis, which are still valid and still maximally efficient from a statistical angle. But there were still some really quirky problems that we had. And one of them was, and I can see these slides don't come out that well on this slide, it doesn't matter too much, but what we found was that there were more people registered with the GP in England than we think exist in England. So it didn't tally with the census data. And what we're showing here is loads of towns or cities along the x-axis, and this kind of difference. And the difference is between 10 and 20% more people registered with a GP. So I thought I'd dive into the northwest because we're in Liverpool, and I thought I'd show you what it looks like for Liverpool. It's kind of 2/3 across, and you can see the red line. This is 2021 GP records compared with this mid-year estimates from the census in 2020, and there's 10% more people registered with a GP than on the census for Liverpool. And actually, if you look across, you start to notice that it's all these kind of university cities that seem to have more people registered with a GP than the census. And it seems quite obvious to us that students might be either registering twice or that we've got overseas students. Anyway, so that was another quirk of the data. And what we had to do is kind of weight the analysis to account for that, and using the census data. We can break this down by ethnicity and by age group, and we have done that. And it's been quite an interesting investigation. Okay, so let's start looking at some of the results. In fact, on the 1st of June 2022, 44% of the UK population were under-vaccinated. It was slightly less in Wales, 30% were under-vaccinated, and up to 50% under-vaccinated in Northern Ireland. And the type of people who were under-vaccinated were male, they were younger, they were living in more deprived areas, more likely to be of non-white ethnicity, and also those living with fewer underlying health conditions. And we then wanted to explore how this was associated with a higher risk of severe COVID-19 hospitalisation. And we specifically looked in the 3 age groups that I showed you at the beginning. And what we see here, these hazard ratios are telling us what the relative risk is of having a hospitalisation and death if you were under-vaccinated. So between individuals aged 5 to 74, we're seeing hazard ratios of between 1.5 and 2. So there's kind of like a 50% or double the risk of having a COVID-19 hospitalisation or death if you're under-vaccinated. But you can see for those 75 plus, this increases to a 3 times risk of hospitalisation or death if they were under-vaccinated. And this is adjusted for a whole host of other covariates to kind of deal with the confounding problems. And then we wanted to kind of say, well, what would have happened if everyone had received their optimal vaccine coverage? So within this 3-month period in summer 2022, we estimated that over 7,000 severe COVID-19 outcomes could have been avoided if everyone had been optimally vaccinated. And you can see that most of these are in the 75 plus. That was nearly 20% of the COVID outcomes that could have been prevented. This was in 2022. We're continuing to update these analyses, and this is one of them. I just wanted to highlight this inequalities by different ethnic groups. So we've got around, I think we've got 13 ethnic groups along the x-axis here. And so again, we're just showing the percentage of those who are under-vaccinated in January 2024. I've highlighted the total, and I've highlighted the white, British or Irish, because you can see that all other non-white ethnic groups have a higher proportion of people who are under-vaccinated. And really, this is a public health message to try and encourage and deal with that here in the UK. So that brings me to the end of the study and the results. I just want to remind you what's enabled this. This is the first analysis that has ever been done covering 67 million people across the UK. And we were only able to do it from the infrastructure that Emily described of having faster approvals and access to linked health data at scale, having this network of trusted and research environments which provide that secure and remote access. This could not be done by one person, okay? We're moving away from that kind of science. It required a multi-institutional but also interdisciplinary team to do that science. Throughout this, we developed a reproducible data management and curation pipelines that can then be applied to future studies. It was strategic, it was coordinated investment, and above all, we needed to ensure that we had these close partnerships with patients and the public to establish and maintain that trust throughout. And they've been involved in all aspects. They sit on our steering group meetings, and they've helped us disseminate this research just because it's so important. But you know what, I'm not here to kind of say this was really easy, because it wasn't. There were some really big challenges and headaches. You'd have a challenge in the English data, challenge in the Northern Ireland. They would be different, and just trying to kind of pull that together. Each data records data differently. Data availability is different, and it's really challenging to write code that's 100% compatible in each of these national TREs. And even just the scale of the data and handling that required workarounds to deal with the computational efficiency. So final slide from me, what have we achieved? We've been able to provide in-depth, instructive results to create this detailed picture of COVID-19 vaccination uptake across the UK, and that supported all levels of decision making. But we've also demonstrated something new for the first time, that we can utilise our health data environment across the 4 nations. And we're now extending this to other areas of medicine to help drive better understanding and prevention of disease. And at this point, I'm going to welcome Emily to do the final slide for us both.
So this is a plea, really. We need you. So don't go anywhere. Please stay. Come and work in some funky health data. Yes, it is a right faff in order to get access to it, but we really need some innovative engineering so that we can actually streamline the processes in which we can access health data at scale in a reproducible way. And those are the sorts of skill sets that bioinformaticians have. So yes, it's a pain, but we really need that sort of work. And I'll stop there. Thank you.
Wonderful, thank you. Questions for Emily and Angela?
Thank you so much for your work and your talk. Really struck some strings close to my heart, because I did mostly cancer bioinformatics for 10 years, and now I'm doing data engineering for BBMRI, the Italian biobank network, because I'm born as a computer scientist. The last slide is really something that I've been working, trying to involve more bioinformatician and people to this very large field that is in the intersection of these 2 fields. What is your take on the education part of trying to include people coming from diverse backgrounds, like also from I don't know, the university paths, like how to make this new kind of research enter the conversation in the education paths, can be PhDs, education, or whatever it is. Thank you again.
Great question, and there's still a lot to be done, but I think we're moving to a better place. So health data research has actually, I think it was 7 years ago, launched a number of new master's programs across the UK, supporting what's called generally health data research, but actually has aspects of this in it. Emily, I don't know whether you want to add anything more to that from a bioinformatics end as well. And then also Health Data Research UK has a large training stream where there's a lot of online videos and short kind of YouTube learning videos, which is both of us kind of feed into that to kind of help to train the next generation to do this aspect. We're not there yet, but I think we're certainly on a route to ensuring that that is happening.
Yeah, I think very much echo that, but I do think there's also an element of coming to things like this to sort of raise the profile, I suppose, of using clinical data and using health data with bioinformaticians that don't just go, that sounds really hard, I'm not going to bother. So it's trying to increase people's enthusiasm, and therefore, if they're wanting to, then there'll then be the routes in order to train people up.
Thank you so much again.
Any other questions?
Hi. So it sounds like the TREs are compute limited, hence the weighted regression you needed to run. Are there any practical technologies available currently or on the horizon, like homomorphic encryption, that would let you process the data outside of the TRE while keeping it secure and safe?
So the compute is actually in AWS in the cloud. So theoretically, extensible on Databricks, et cetera, but it's actually the sheer. This is not. Let's put it on a HPC and it'll fix it all. This is already very much set up for large compute. We are doing some research on how you could move a TRE in a containerized way to run it on HPC, in terms of that's what some of the innovative engineering and the projects that we're doing there. The homomorphic encryption is challenging in terms of how you assess independently that has been done appropriately in such a way that you're then happy to do the data sharing and then you can run on it. And it also has challenges around the interpretation of the answers and stuff that then come out. So yes, that's very much the sort of area that we're wanting innovative skills to come and look at, and those are the exciting bits of research that we're wanting to do.
And I just want to add to that, because I don't think we should be running analyses on massive data sets just because we have the data available, when there are statistically efficient ways to do studies and analyses which don't require you to use all the data anyway. And we should have in mind green algorithms, or the way in which we conduct these analyses, so that they are energy efficient as well. And I think we shouldn't be doing these kind of big analyses for the sake of it. I really think of thought as we go into the future of using such big TREs and computational capabilities.
We're running slightly behind from the technical difficulties at the start, so one last question.
Thank you. Thank you. Well, so it's along the lines of this topic. I wonder, what are your thoughts on equity of access to the technology? So in order to be able to run analysis that on data, at least on a TRE, you need funds, resources to access virtual machines and do a variety of runs. What might hinder as well experimentation, particularly for more junior members in the career, and also splits across organizations or even countries, if we were to think outside the UK, will limit a lot what we could do as a community. So what are your views on how we can make this more accessible for everyone?
It's a massive challenge. So if we just take the UK, we've actually got quite a mixed model. So if you're looking at doing research in trusted research environments for administrative data, that's all funded by a big grant, which means that at the point of access, it's free, and you just have to put in an application to do it. Within health, it's based on a cost recovery model, and you need to put that down as a proportion within your grant. So actually just which model do you then use? I don't have any clear answers. It's a massive challenge. Absolutely.
I nothing to add.
Thank you.
Okay, can we thank Angela and Emily again?